Okay, so let's talk about distance. So, how would you find the distance between Upland and Huntington Beach? This is a rough sketch, right? Because, I mean, we're about right there. So how far would it be to get from Upland to Huntington Beach? Can the Cartesian coordinate system help us find the distance? An XY plane. Can it help us find the distance? Because it's a point, right? What about if I did this? What does that look like? Good job. It looks like the Pythagorean theorem, right? How far did I travel on the x-axis? 4. How far did I travel on the y-axis? What do I normally do with those numbers? I square them, right? I know you can't see it very well, but we're going to see it just fine in a minute. What's the area in here? 16. And what's the area in here? So what's the area in here? If the area is 32, what is the side of this square? Square root of 32. You guys are awesome. You don't even need me to teach you. Okay, so let's start our lesson. The distance formula, this is my big idea. We can compare distances to the legs of right triangles. So if the the Pythagorean theorem says c squared equals a squared plus b squared, on a coordinate plane we would call that distance squared equals the change in x plus squared plus the change in y squared. Isn't that what we found? We found the change in x was 4, and the change in y was 4 as well, and then we squared them, and then we took the square root of both sides. Correct? So isn't this the same as this? Only it looks like this. So Pythagorean theorem, we start with the squares. Distance, we start with the square root. Don't we eventually get to the square root in the Pythagorean theorem? Right? What was the last step that we did on this one? Take the square root, right, to find the side? You'll see. Let's keep going. So find the distance from point A, if they gave us a point, to point B. So if these are your x values, and these are your y values, all we're doing is finding the difference between 1 and -3, which would be here, and the distance between 8 and 4, which would go here. Right? That's what we did in the last slide. So the distance squared would be 16 plus 16. Or distance squared equals 32. What's our last step? Take the square root. So distance equals square root of 32, or if I were to simplify it, it would be 4 root 2. So you see what I was saying about the last one, where this one starts with the squares and ends with the square root? Distance formula starts with the square root. Same thing. Let's keep going. So I'm going to do this officially the way this is the distance formula right here. The difference between my x-coordinate and my other x-coordinate added to the difference between my y-coordinate, and then take the square root. That's the official distance formula. I'm going to do it for you once, and I'm not going to ask you to do it like that again, because I would much rather you do it conceptually. Okay? So just bear with me. So distance means difference. What does difference mean? What operation is that? Subtraction. So I'm going to find the difference between two numbers, just like we did in our warm-up, right? We were finding the difference between two numbers on the on a vertical line and the distance horizontally, right? That's why I had you do that. So distance means difference between two places. Find the distance from point A, right here, to point B, which is right here. So first I'm going to go ahead and label my coordinates. This is x1, and this is x2. This is y1, and this is y2. I'm going to go ahead and jump right to this step and say, no, I'll do that on the next one. Okay, we'll do this formally. I just hate to. Okay, x sub 2 is -3. X sub 1 is 1. If I want to find the difference, I have to subtract them. Y2 is 4. Y1 is 8. If I want to find the difference, I need to subtract them. -3 and -1 is -4 squared. Plus, +4 and -8 make -4 squared. So far, the only difference between the way we did it originally with the Pythagorean theorem and the way we did it with the distance formula formally is the negative signs, right? But what happens to those negative signs? They go away. Why? Because I'm squaring it. Aren't I always going to square it? In this formula, aren't I always going to square it? So this is going to be the square root of 16 plus 16, which is the square root of 32. And let me just show you how I did that. 2 16s, right? 16 times 2, which makes 4 squared times 2, which makes 4 root 2. Or, looking at it this way, I need to estimate. What would be an estimation of the square root of 32?
5.
You did that fast. Why did you say 5.6? Because the square root of 36 is 6, and the square root of 25 is 5. Excellent. Let's go back up and look at our steps. Yes. Yes. That's what we did. I'm doing the exact same problem we did earlier, only I'm using the formal distance formula. But I'm going to show you why you don't need to use the formal distance formula. Okay? Ready? Identify x and y values. We did that. Draw out my distance formula. Find my change in x and my change in y. I did that by using my coordinates. Substitute those in and simplify. Let's try another one. Miss Wiz's ball is much closer to the hole than Mrs. Mahler's ball. Here's Miss Wiz's ball. Here's Mrs. Mahler's ball. How far apart are they? So this time I don't have any of my formulas here. So I'm going to start off fresh. So first thing I'm going to do is I'm going to identify my x and y values. So my first coordinate is at -2, 3. And my second coordinate is at 8, -20. Distance formula. Well, I know distance is related to the square root of something squared plus something squared. Specifically, my change in x and my change in y. Correct? Let's find those changes. How far do I have to go on the x-axis to get over to here? Let's see. These are counting by 2's, or I could just look at this value right here. If this is my x value, and this is my x value, how far is it to get from 8 back over to negative 2. 10. Let's draw this out and start filling this in now. If you don't want to draw a graph, I'm going to show you both ways, graphically and using the points. If you don't want to use a graph, you can simply look at your coordinates. Look at these coordinates up here. So the difference between negative 2 and 8, if you visualize it, is 10. Right? Because if you're at 8, you've got to go all the way to 0, and then you've got to go 2 more to get to negative 2. Right? So if you can visualize that, that goes here, or you can visualize it with our drawing here. And how far do I have to get to go from, here's my y value, negative 20, all the way up to 3, without even drawing it? How far is it to go from negative 20 all the way up to 3? Not negative 23, just 23, right? So to go all the way up here, I'd have to go 20 up and then 3 more. Everybody see that? And I'm finding a distance from this point to that point. Let's finish this up. So distance equals the square root of 100 plus 23, oh I forgot my squared. 23 squared is 529. Your numbers on your homework won't be this big. I just thought this was a really cute example. I saw this in the book and decided to make up a word problem. Okay, so 100 plus 529 is 629. I know that, let's see, 25 squared is 625. And 26 squared is 676, I believe. I think I'm right. So it would be about 25.1. Right, so that's how far apart they are. Okay, does that make sense? Go back and look at it. Does it make sense? If this is 10, and this is how much? How much is my change in y? 23. This would have to be more than 23, right? So 25.1, it makes sense. Whoops, wrong color. 25.1. All right, get your whiteboards out. Let's do this one together. So what I want to see, I gave you the distance formula here with your steps. But all I'm requiring from you is to tell me, I want you to write d equals the square root. I want you to tell me what my change in x is and my change in y. So in this format, whichever way you want to get to it, whether you want to graph it or whether you want to just look at the points and figure it out, or if you want to put it into the original distance formula, I need you to tell me the change in x and the change in y. What does it mean to be the change? What does that mean? What does it mean to be the change in x? The distance between them, right? The change is the distance going from one point to the other. So on your whiteboards, tell me the distance it is to go from, let's get rid of this. Show me the distance between your x's and your y's. So, graphically, if I'm going from this point to this point, I had to go a distance of 3. My change in x is 3. And to go from here to here, on the y-axis is also. Change in y is also 3. So when I add these together, give me my final distance on your whiteboard. Okay, so most of you got 9 plus 9, right? Which is the square root of 18. Some of you went directly from here and said, if the square root of 18 is between what? Two numbers? 4 and 5? Then this is about 4. That's the most common, I thought, was 4.2. But the most accurate answer would be, this is 2 9s, or 2 times 3 squared, which is 3 square root 2. So on the homework, they're going to expect you to find the square root answer and the estimation. Okay? But not all of them will simplify down like this. Let's try another one. This time find the distance between points -3 and -5 and -6 and -4. -3, -5, -6, -4. Graph it, look at it, and just find the distances between. However you want to do it, I need to see the change in y and the change in x on your whiteboard before you go any further. We'll pause. All right, let's plot this. -3, -1, 2, 3, 4, 5. Wrong color. And -6, -4. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. So I need to find the distance between these 2 points. Michael, walk this with me. If you're at -3 and you go over to -6, how far did you have to walk? You don't even need the negative. The change in x is just 3, right? Because distance is never negative, right? You went -3 in the negative direction, right? But you only walked 3. So then, how far do we go if we start at -5 and we walk up to -4? How far do we walk? 1. So now I know that the distance must be 9 plus 1, which is root 10, or about what? I'm going to say 3, you think 0.8? I would say like 0.2. You would be right if you're like anywhere between 3 and 4, right? I wouldn't mark you wrong as long as you're between 3 and 4, but 3.9 is really close to 16, right? And we got, you're going to put 3.4? That would be a reasonable guess, right? Okay. Okay, time to record what we've learned. So in your notebook, write down the steps and example 4. Actually, which example do you want? Probably this one? Got more? Which one do you want? Okay, so write this example down in your steps. Okay, so let's wrap it up. What did you learn today? Distance formula, exactly. What is the difference between the distance formula and the Pythagorean theorem? No. The distance starts with the square root, Pythagorean ends with the square root. That is the only difference between the two of them, right? They're both finding changes in x and changes in y and squaring the sides of a triangle, right? Okay, John was lucky enough to get a pass to the restroom today. This is my way of, John always wants to go to the restroom, and I never let him go to the restroom in period 2. John Seeker. I mean, is John Seeker. John was lucky enough to get a pass to the restroom today. When he returned, he just wanted to know the easiest way to find distance for his homework tonight. What do you tell him? Somebody raise their hand and tell me the steps. What's the easiest way to find the distance? Using the Pythagorean theorem, okay, but tell me more specific.
Finding the change in y, change in x, and then go from there by using the Pythagorean theorem.
Good.
Until you have just there.
Awesome. Awesome. So she said, find the change in y and find the change in x and use them in the Pythagorean theorem and go all the way until you take the square root, right? Good job. All right, guys. Do your homework.